Welcome back. Let's evaluate the double integral of x plus 2y over the plane region D, where D is bounded by the parabola y is equal to 2x squared and the parabola y is equal to 1 plus x squared. So the parabola, the first parabola has vertex at the origin, and the second one has vertex at the point 0, 1 right here. So the first thing we need to do is make sure we understand where the two parabolas intersect. So how do I find the intersection of the two parabolas? Well, at the intersection, the y values should be the same. So we set 2x squared equal to 1 plus x squared. So then from here, if we subtract x squared from both sides, we get x squared is equal to 1, or x is plus or minus 1. So we see that we have two intersection points at -1 and 1. We have intersection at -1, 2 and at 1, 2. Now so D is the region between, that is below the parabola y is equal to 1 plus x squared, and it is above the parabola y is equal to 2x squared. Now D is a type 1 region because we can see that the reason it's type 1 is because here we can see that x is between -1 and 1, and then for each x, so if we fix a value of x between -1 and 1 and make a vertical line, the vertical line is going to intersect D at a vertical segment. And notice that along the vertical segment, y goes from 2x squared to 1 plus x squared. So y goes from 2x squared to 1 plus x squared. So this is a type 1 region. This is vertically simple. So the double integral of x plus 2y over D is equal to the iterated integral, where we have the integral from -1 to 1. X goes from -1 to 1. Y goes from 2x squared to 1 plus x squared, x plus 2y dy dx. So we integrate with respect to y first. The integral, so when we integrate with respect to y, x will be treated as a constant. So the integral of antiderivative of x with respect to y would be x times y, and the antiderivative of 2y with respect to y would be 2y squared over 2, which is y squared. Evaluate this antiderivative at the two limits here and subtract, so we get x times, so again we are substituting these two limits for y. So we get x times 1 plus x squared plus 1 plus x squared whole squared, and then minus x times 2x squared and 2x squared squared. So this is what we get. And then we have to simplify this expression right here, and which means that we have to multiply out everything. So we get x plus x cubed when I multiply here, and when we expand this square, we get 1 plus 2x squared plus x to the 4. Here we get 2x cubed. Here we get 4x to the 4. All right, so now we cancel out whatever we can, and we end up with -3 x to the 4 minus x cubed plus 2x squared plus x plus 1. So that is, this 2 is going to give us -3x to the 4 with this negative here. We got a -2x cubed and a positive x cubed here, so that's -x cubed. We get 2x squared here. We get x here and 1 here. Well, now we integrate that with respect to x, and which is pretty easy to do. So we get -3 x to the 5 over 5 minus x to the 4 over 4 plus 2x cubed over 3 plus x squared over 2, and for this one we get x. All right, so now we have to plug in 1 and minus 1 and subtract. So I will leave that as an exercise. Okay, so that's how we can compute the double integral over a type 1 region. In the next video, we'll be seeing more examples.